Right. Let's talk probability today. Probability is how likely an event is to occur. We can express it in three different ways: as a ratio, a decimal, or a percent. And the probability will always be a number between 0 and 1. The formula is fairly straightforward. You take the favorable number of outcomes and put it over the total number of outcomes. We express it when we're trying to find the probability of event. Like, say we're rolling a dice, we would put P, and if we wanted a 6, we would put P and put 6 inside of the parenthesis, and we find the probability of rolling a 6 on a dice. Okay, just some vocabulary. An outcome is a possible result of a probability experiment. Okay, an experiment can have many outcomes depending on what the experiment is. An experiment is what's taking place, such as flipping a coin or rolling a dice. So if we're flipping a coin, there's two outcomes. You'll either have a heads or you'll have a tails. If you're rolling a dice or a number cube, you're going to have 6 different outcomes. An event is the outcome or outcomes that we want. Okay? So going back to that probability of a 6, that 6 is what we want to happen. A sample space is all the possible outcomes of an experiment. Okay? The complement of an event is a set of all the outcomes in the sample space that are not the event. So think back to that dice again. We wanted a probability of a 6. Well, the sample space for rolling a dice is 1, 2, 3, 4, 5, and 6. So the outcome we want would be the 6, the event. The complement of that event would be 1, 2, 3, 4, 5. Basically all the ways I can lose, okay? I only win if I get that 6. So take a minute, get this written down if you need to, and we'll take a look at a couple of experiments. Give this time to pull up here, okay? The first, we want a probability of spinning this spinner and getting an orange. Remember, our formula was our favorable outcomes over total outcomes. Well, favorable for us is going to be if we land on orange. There's only one orange on this wheel, so the first number is going to be, the top number will be a 1. That's our favorable outcomes. That's the event. Then the bottom number is the total number of outcomes. Well, there's a total of 8 outcomes on this. There's 8, it's divided into 8 sections. So the probability of spinning the spinner and it landing on orange is 1 out of 8, okay? For the probability of a green, again, it's the same spinner, so we're talking about, there's still 8 total outcomes. And the event that we want to happen is landing on green. 2 of these are green, so it's going to be 2 out of 8, okay? Which will reduce down to 1/4. Remember, we're going to express it in simplest form, okay? And then for the probability of a blue, there's how many blues? There's 3 blues. There's still a total of 8 outcomes on this. 3 over 8 is already in simplest form. We can't reduce it, so we're going to leave it there. And then the next thing is the probability of getting a red. Well, since there's 2 reds, those are our favorable outcomes. The total outcomes is still 8. And again, as it was with green, this is going to simplify down to 1/4. Okay? So that means for that, it means 1 out of every 4 times we spin, it ought to land on a red. So I should be able to spin that and got an orange on the first time. Got a blue. Got another blue. Got another blue. If we did this a total of 8, let's see what we get. Nope. That's 5 turns. Oh, we finally got one. That's 6. No one of these next 2 need to be a red for this to hold true. Held true. Okay. In a little bit, we'll talk about what type of probability that is and the difference between theoretical and experimental probability. We'll talk about that later. Let's go ahead and look at another example here. Now we're rolling a dice or a number cube. Remember, how many outcomes did we say there were to a standard number cube or dice? 6. And we're trying to find the probability of rolling and it landing on a 2. Okay, well there's only 1 2 on this dice, so it's going to be 1 out of 6. So that means if I roll this 6 times, one of those times, theoretically, I should get a 2. We know from playing board games with dice that it's not always going to work like that. We might get 3 2s in a row, or we might not roll a 2 for several times. So the next one is the probability of it landing on an even. Well, how many evens are there on a number cube? That'd be 2, 4, and 6. So there's 3 of those. So that'd be 3 out of 6, and that'll simplify down to 1/2. So the probability of rolling an even number on that is 1/2. Next is the probability of getting a number less than 6. Well, how many numbers less than 6 are there? 1, 2, 3, 4, 5. So that's going to be the probability of 5 favorable outcomes out of 6 total outcomes. The next one says the probability of something getting something greater than a 2. Well, the numbers greater than 2 on a number cube are 3, 4, 5, and 6. So we'd have 4 of them. So 4 favorable outcomes out of 6 total outcomes. That one will simplify down to 2 over 3. Okay, a little different example here. This one is talking that the top is the grade made on a, say it's a test. There, and the bottom is the number of students. So there's 2 students who made a 65, 13 students who made a 70, 10 students who made an 80, 7 students who made a 90, and 2 made 100s. We're trying to find the probability of a student making a 70. Well, what's going to be our total number? Is it going to be the grade, or is it going to be the number of students? Well, it's going to be the number of students, so we need to add up the number of students. So I've got a 13 and a 7, that makes it 20, plus 10 is 30, and then 2 2s, so 34. So our bottom number is going to start out as a 34. And then we want to know the probability of making a 70. Well, and if we're going to say, and that's exactly a 70, so there were 13 students who made a 70, so the probability of that happening would be 13 out of 34. The next one says the probability of making greater than or equal to an 80. So we're still with our 34 total outcomes. And now our favorable outcomes are anything that's 80 or above. So we look there and we have 10, 7, and 2, so that's 19. Well, 19 out of 34 isn't going to simplify, so we're going to leave it there. On the next one, it says the probability of less than 80. So that doesn't include 80, so we're just talking less than 80. So we're talking about these 13 and these 2, so that's a total of 15, still out of that 34 students. Okay? The last one is the probability of getting exactly a 60. Well, did any students out of our 34 students score 60? Okay, well, that's 0 over 34, or that's just 0. That's not going to happen. Okay, that event cannot